Let me
Hello,
communicate.
sir.
Yeah, bolo bolo. Presentation, and I'm going to do some board works right now. Okay, so let us do some board work. Then I may again come back to, I may again come back to, uh, I may again go back to the Excel sheet to show you the uh, correspondence between my board work and the Excel sheet problem. Someone is unmuted. Please mute yourself. Please mute yourself. Who is unmuted? Okay. So, okay, let us do some board works, and let's see what happens. So you see, just a minute, hold on. I'm going to discuss a problem right now with you. I'm going to discuss a problem right now with you where I am going to show you something which is also very important. It is actually a theorem, which the theorem says that two independent two independent this theorem is very important, this problem is very important, and it often comes in the examination. Two independent variables are uncorrelated. Try to understand this particular theorem carefully. It's very important and people often neglect it, this particular theorem. So I'm highlighting it over here, very important. Two independent variables are very important. What do we mean by independent variables? What do we mean by independent variables? That is very important part you have to understand, because actually, although we are learning correlation right now in this particular semester, later what happens that you will be in this, when you will be in the second semester, you will learn the probability course, and the probability, the independent variables play a significant role in probability theory. So independent variables, to be brief, it says that if the choice of one variable, say capital X, does not depend upon the choice of another variable, you note it in your copy, another variable, say capital Y, or vice versa, then the two variables capital X and capital Y are called independent, the two variables are called independent. Say for example, a person is there, P1, he is tossing a coin. The person is situated in Kolkata, he is tossing a coin, so he may get two items, say two outcomes, one is head and another is tail. So I can write this person as PK because he is situated in Kolkata, and his head, the coin he is tossing, the head is represented by HK and the tail he is getting is represented by TK. Another person is situated in Delhi, so I'm denoting that person by PD. So when he is tossing the coin, he is getting the heads HD and TD. Now these are the outcomes these people are getting, but his outcome, the outcome this is not dependent upon the outcome that, because you cannot say that if this person gets a head in his coin, that person will also get head in his coin. So these are actually not related to one another, they are called independent variables. So independent variables are those variables where the choices are not independent, the choice of one variable is independent of the choice of another variable. So the theorem says that, let me highlight the theorem. The theorem says that whenever there is two independent variable, they are uncorrelated. So what does it mean? It means that there is a theorem, the rule says that for, it is actually a formula. but derivation of the formula is a subject matter of module 2. The teacher will tell you. I am just using the rule. For two independent variables, capital X and capital Y, two independent variables, capital X and capital Y, covariance between X and Y, or sometimes it is denoted by cov X comma Y, this becomes 0. Remember this. This becomes 0. It can be proved. The teacher will tell you. Whoever is teaching you statistics for whoever is teaching you module 2, she will tell you about how to solve this particular thing, because it is not my job to do, because it is not under the module 3 section. I'm going to use this result over here. So since for two independent variables covariance between capital X and capital Y is 0, then what happens? Then you know the correlation coefficient Rxy is given by the formula covariance of X comma Y, and it is divided by the product of these two terms, sigma X and sigma Y. So when covariance of xy is 0, then we can put over here 0 and the result becomes 0. Okay, and this implies that for two independent variables, capital X and capital Y, the correlation coefficient is 0, or two independent variables are uncorrelated. Two independent variables are uncorrelated. So this result is proved. Okay, fine. But my job is not yet done, because I have to. The important part of this particular, you may think that this is very easy to understand. So actually, why sir is writing very important over here. So the important section has not been decided, has not been discussed yet. So you first copy it, and then I'm going to get into the next slide to show you the important part, which I want to talk about actually. So if you are done, you can write in the chat box that yes, you have done, and then I can go to the next slide. Quickly copy it, and then I'm going to show you the next part of the calculation. Okay, so okay, fine. Then the theorem, this theorem has another part. This theorem has another approach when it asks whether two uncorrelated variables are independent. That means the reverse of that. Okay, so independent, this word independent implies uncorrelated. We have already proved it. Okay, we have proved it. So let us write here proved in the previous page. Now our job is to show, now to check whether uncorrelated variables, independent. Whether uncorrelated variables independent. So that we want to check right now. So for this, what I need to do is that I am going to take a table, a chart. This chart contains some items in it. Let us write the items. -3 is there, -2 is there, -1 is there, 0 there, 1, 2, and 3. This, how many items are there? 7 items are there. So let us not take the 0 over here, because 0 will not change anything. 0 is just we can avoid it for the sake of the problem. And we can take the values of y in this manner. So we can take the value as 9, and then we can take the value this as 4, that as 1, this as 1, this as 4, and that has 9. This is the bivariate distribution I am considering. This is the bivariate distribution I am considering. Okay. So when we find the correlation coefficient, what we need to do, let me write, probably you have seen in my video that correlation coefficient is given by this formula, covariance of xy by sigma x into sigma y. And covariance of xy is given by the formula in turn as 1 by n summation xy minus x bar into y bar. And sigma x squared is given by the formula 1 by n summation x square minus x bar square, where x bar is the arithmetic mean of x, and sigma y square is given by the formula 1 by n summation y square minus y bar square. Okay, so we need to find the xy first of all. So if I write xy here, that means we are going to take the product of these two. So it is minus 27. This is minus 2 into 4, that is minus 8. This is minus 1, that is 1, that is 8. These are the values, and that is 27. Okay, so I have taken the product of the two items, x and y. If you take summation of these items, if you take the summation of these items, what will you get? Let us find it out. If you take the summation of this item, what you get? You get minus 27 plus, sorry, let me write it in this manner. We will get minus 27, minus 8, minus 1, plus 1, plus 8, plus 27. And what is it? It is actually 27 cancel 27, 8 cancels 8, minus 8, 1 cancel minus 1, and the result is 0. So, and if we want to calculate x bar, if you want to calculate the arithmetic mean x bar, let us try to find it out. Arithmetic mean is given by the formula. Arithmetic mean, let us write the formula of the arithmetic mean first of all. So arithmetic mean is given by everybody knows the formula. It is x bar is equal to 1 by n summation x. So summation x, let us calculate it. Summation x is what? Take the values of the sum total of this, minus 3, minus 2, minus 1, plus 1, plus 2, plus 3. And similarly, we can cancel the 3 cancel minus 3, 2 cancels minus 2, 1 cancels minus 1, and we get the result 0. Okay, so from these calculations we have found that since summation xy is 0, Therefore, if we divide summation x, how many items are there, by the by? How many items are there? N is equal to how many items? 6 items are there. Okay, so if I divide this summation, by 6, that is also 0. And if I divide this summation by 6, that is also 0. And when we divide this summation by 6, that is actually your x bar. So what we are getting the covariance xy as, look at the formula of covariance xy. It is 1 by n summation xy minus x bar into y bar. So from here, actually we are getting 0 minus x bar is 0. Here x bar is 0 and y bar. We don't have to calculate it because the result is 0. So we have got the correlation, we have got the covariance of xy as 0. We have got the correlation coefficient as 0. Now, once the covariance of xy is 0, let us put a star over here and let us write the remaining portion of the calculation in this place. Once the correlation coefficient is 0, covariance of xy is 0, the correlation coefficient rxy, since it is given by the formula which has been written over here, so the numerator becomes 0 and we are least bothered about the denominator, and that is 0. So you see, the problem is showing us that the correlation coefficient between the two variables are 0. So what does it mean actually? It means that when we take the variables capital X, Y in this manner, this was my distribution. Okay, and for this particular distribution, we have found that Rxy is actually 0. So this implies that capital X and capital Y are uncorrelated. But the question is, are they really independent of one another? So if you observe very carefully these two variables, if you observe them very carefully, you will notice that actually the variables capital X and capital Y are not independent. Why? Because I actually squared -3 to get 9. I actually squared -2 to get 4. I actually squared -1 to get 1. Then, oh sorry, again I have written 0 over here, but 0 was not there in my chart. Okay. And when I take square of 1, we got 1. When we took square of 2, we got 4. When we took square of 3, we got 9. Okay, and that means in general you can write it as your capital Y is actually capital X squared. So there is a kind of relationship between the two. So they are not independent. So what is the difference? The question is, what is the meaning when we say two variables are uncorrelated but not independent? What is the meaning of this? They are uncorrelated but not independent. What is the meaning of this? The meaning of this is uncorrelated actually means there is no linear relationship between the two variables. There is no linear relationship between the variables. What do you mean by that? What do you mean by that? That means if we plot these two variables, in the chart, the graph will not be straight line. If we plot the two variables in the chart, the graph will not be straight line. That is the meaning of uncorrelation. Graph will not be straight line. Won't be straight line. Okay, and when we say that the variables are uncorrelated, that means that there may not be any linear relationship between the two. But non-linear relationship between them may prevail. Non-linear relationship between them may prevail. Okay, what is that? This is a non-linear relationship. This is called a non-linear relationship. This is called a non-linear relationship. Okay, and you see, what do we mean by non-linearity? Non-linearity in the relationship, it means that if we plot the two curves, if we plot the two figures in the graph paper, the result will be a curve and not a straight line. So the result will be a curve and not a straight line. So you have to understand very carefully what the difference between, if you understand very carefully the difference between the linearity and non-linearity. When we say that the two variables are uncorrelated, then that means there is no linear relationship between them, but non-linear relationship may prevail between them. Okay, I'm going to show this particular example with the help of the software once again. Then when you see the curve in front of you, you will understand what I mean to say. Okay, so I'm going to share my Excel sheet once again, and you see I'm going to this particular section. I'm going to talk about this particular section where I considered this particular chart where x was having the value -3, -2, -1, 1, 2, 3, and y is like this. I'm going to select this particular chart, and I'm going to, first of all, I'm going to find the correlation coefficient between them. Okay, so for this I have to select a blank cell, and then I'm going to double click on it, and then click on more functions, go to statistical, find correl, and here you find this A2 to A7, and for array 2 you find this, and you see the correlation coefficient is 0 in between them. So what I found manually, it is true over here. Let us show you the figure now. The figure looks like this. So if I plot the figure, insert, scatter, and you see how does this figure look like. Let me make the picture. See, this is the tendency of the points is a curved tendency. It is like this, kind of smoothed U or smoothed V, or you can say a little bit like U. So it is like this. So this cannot be a straight line at all. This particular thing is a curved line. Okay, so between the two variables, a nonlinear relationship is prevailing, but no linear relationship is there, and therefore the correlation coefficient between the two variables is 0. So that is what we have done in the board work. So let us go back to the board work once again, and you will see that, yeah, that is the thing which is happening over here. Okay, so at this point, I'm actually moving very slowly with this correlation coefficient chapter, because you see, if you go by the syllabus is actually having the correlation in module 3. And unfortunately, I am supposed to teach you module 3 and module 4, which comes later, which is the part of applied statistics. And this comes when actually you will be in a position to learn these subjects, when learn these topics, when you are actually much acquainted with module 1 and module 2, especially module 2. Okay, so therefore this particular thing needs to be discussed once your module 2 is complete. But unfortunately, because the two teachers has to start the classes simultaneously, I cannot do this kind of thing that the other teacher will end and from then on I'm going to start my class. In that case, the syllabus will not be completed. So I had to start the section. I had to start this particular module from the beginning. That's why I'm actually moving much slowly, so that you get sufficient amount of time to cope up with it. Okay, so for example, the problem which I have discussed right now, that problem has not been will not be discussed in BBA section C, because if I discuss the same thing, then I'll not be able to finish the syllabus. It will kill the time. So I will keep myself in the domain of the correlation. We'll discuss a different set of problems. Okay, and I will upload both the videos and will share the video with you, so that both the sections can see it together. In that case, I will be able to do sufficient amount of problem in this online session. So this much I actually wanted to say. And tell me if you are not actually, if you have any question, then you can unmute yourself and you can ask me. Anybody, any question? Otherwise, I'm going to end the session for today. So I'm waiting for your questions. If there is no question, then you can quietly leave. I will point and we'll meet again in the next class. Maybe my next class will be after Christmas vacation. So let's see what the notice hasn't yet come. So let's see what. I hope that you have understood and you have actually got my point. You are understanding my teaching. I don't know whether I teach well or not, but I'll try my level best to make you understand. And the rest is up to you. If you study, then you'll get to know the things. So please don't depend on my notes and my videos only. You also study the book which I upload in the Google Classroom. Please go through the book. This is a wonderful book, and I have the book with me, so you can take the reference from any page. You can ask me and we can discuss it in the classroom. So bye for now. See you in the next class.